Assalamualaikum and a very good morning everyone. Today we will present you about the application of gravimetric analysis in water quality testing. Before we begin, let me introduce you to our team. Firstly, I am Haziq, and with me are Zulikwan and also Izani. What is gravimetric analysis? Gravimetric analysis describes a set of methods in analytical chemistry for the quantitative determination of analyte based on their mass, and it's very accurate and reliable when done it correctly. Moving on, water quality is considered the main factor controlling health and the state of disease in both man and animals. Surface water quality in a region is largely determined both by natural processes such as weathering and soil erosion, and by anthropogenic inputs such as municipal and industrial wastewater discharge. The anthropogenic discharge constitute a constant polluting source, whereas surface runoff or seasonal phenomenon largely affected by climate within the basin, according to Singh et al. 2004.
These are the three types of gravimetric analysis. First, we have volatilization gravimetry. This method involves heating the sample to remove volatile components like water or carbon dioxide. The mass loss during heating is measured. This type is commonly used to determine total dissolved solid, moisture, or biomass in water and soil. According to Harvey D. 2024, this is especially useful for environmental and agricultural samples. Second one is precipitation gravimetry. This is a quantitative method where the analyte is converted into a soil precipitate. The precipitate is then filtered, dried, and weighed to find out how much of the analyte is present in the original sample. This method is very accurate and widely used in laboratories. Lastly, we have electrogravimetry. This involves using electrochemical deposition to isolate the analyte. The analyte is deposited onto an electrode and then weighed. It's often used for metals and conductive substances. These three types each have their specific application depending on the nature of the sample and the substance being analyzed. I'll be talking about a real-world application of sulfate determination in water. Sulfate analysis is very important, especially in environmental monitoring and industrial water treatment. Monitoring sulfate level helps us avoid several serious problems. Firstly, excess sulfate can lead to pipe corrosion, which weaken infrastructure and cause costly damage. Secondly, scaling in boilers is another major issue. When sulfate combines with other materials, it can form hard deposits that reduce boiler efficiency and increase maintenance costs. Lastly, high sulfate concentration can harm aquatic ecosystem, affecting water quality and damaging marine life. That's why it's crucial to determine and control sulfate levels in water, ensuring safety and sustainability in both industrial and environmental contexts. Now let's look at how gravimetric analysis is used to test sulfate in water. First, we take a known volume of water, then we add barium chloride. This reacts with sulfate ion in the water to form barium sulfate, which is an insoluble solid. We write this reaction as SO4 2- plus Ba2 plus equals BaSO4 in the bracket S. The barium sulfate precipitate is then filtered, dried, and weighed. From the mass of BaSO4, we can calculate how much sulfate was originally in the water sample. This method helps us know the sulfate concentration accurately.
Let me explain how the experiment is done in simple steps. Firstly, we make sure the eyedropper is clean before using it. Second, pour a measured amount of barium chloride solution into a small beaker. Thirdly, use the eyedropper to add the solution drop by drop. Not let the barium chloride touch the rubber bulb of the dropper. And this method lets you add the solution where the beaker are still heating in hot pads. Second demonstration, filtering using ashless filter paper. Firstly, use a glass or plastic funnel with ashless filter paper. Ashless filter paper is made of pure cellulose. It burns completely when heated, leaving no residue. It also breaks down into water and carbon dioxide. The filter paper is shaped in circles and it must be folded properly to trap all the barium sulfate. The third demonstration is pouring the solution. Firstly, near the end of pouring, a steering rod is placed across the top of the beaker to keep it steady. Secondly, the beaker's lid should be close to the funnel to avoid spilling. One problem here is that the solution falls form too high. To avoid splashing while using the solution, the falling distance should be made shorter. The fourth demonstration, filter paper leak, what happened and what to do. The filtrate in the small beaker is cloudy due to leakage to all around the filter paper. The students should have placed a new filter paper under the old one and continued filtering. Then they should have filtered again. Wash and ash both filter papers. Instead, the student washed the participant back into a filter mixture and threw away the old filter paper. Covering the old paper from the trash is not safe. It may be contaminated. Now, student must choose to either risk a low result or start the process over. And lastly, the filtrate in the larger beaker is clear, showing that it was filtered correctly. The fifth demonstration, folding and ashing filter paper. Firstly, we need to fold the filter paper to keep the precipitate inside. Make sure the final shape fits into a clean pre-weighed crucible. It's okay if the paper is still damp, it may be easier to fold. Do not tear the paper when folding or precipitate may be lost. Place the paper into the crucible and start heating. As heating continues, the paper will blacken and may catch fire. Keep the crucible cover nearby to put out any flame and prevent pieces from flying out. The final image shows the crucible before final ashing. The sixth demonstration, after heating the crucible, firstly let the crucible and the cover cool completely and gently separate the two parts. You see tar and carbon residue in the rim and inside the cover. Heat both parts again to burn off all the residue. If you think barium sulfate might be on the cover, weigh the cover after heating, then wash it, dry it, heat and wet it again. Usually, barium sulfate doesn't stick to the cover and also this is very rare. And lastly, as the result, as you can see, the carbonaceous material on the underside of a cover can be quickly removed by heating it upside down. The one at the bottom was heated as shown and the pure carbonaceous material oxidized and disappeared in a matter of minutes. And this is the result of the demonstration that according to LibreText 2025.
This is a sample calculation. importance in industry and environment. Gravimetric analysis continues to play an important role in both industry and environmental monitoring. And let's look at three key areas where this method is widely applied. First, in municipal water plants, gravimetric analysis is used to check the concentration of certain ions like sulfate or chloride in the water supply. This helps ensure that the water is clean, safe, and meets the national drinking water standards. Accurate measurement is important to prevent health issues caused by excess minerals or contaminants. Second, in industrial sector, especially those involved in chemical production, mining, or manufacturing, this method helps monitor the content of solid materials in wastewater or product samples. Companies use this data to improve product quality and make sure they are not polluting the environment. Third, in environmental labs, gravimetric analysis is trusted for its precision. It is commonly used in research and environmental monitoring programs to analyze pollutants in natural water bodies like rivers and lakes. Scientists rely on this method when they need accurate data for reports or legal documentation. Although the process requires careful handling and patience, industry continue to use gravimetric analysis because it delivers reliable and consistent results. That's why it remains a valuable technique in both modern science and industry. To conclude, gravimetric analysis remains a robust, accurate, and precise technique for water quality testing. It is especially useful for measuring key parameters like total suspended solids (TSS), total dissolved solids (TDS), chlorides, and sulfates, which are important indicators of water safety. Its main strengths lie in the direct measurement of mass. By filtering, drying, or evaporating samples, then weaving the residues, we can obtain highly reliable results as long as the correct protocols are carefully followed. However, it's important to acknowledge that gravimetric analysis is also time consuming and requires very careful control of the process. If the reagents or environmental conditions are not well managed, the accuracy can be affected. Despite the rise of faster modern instruments, gravimetric methods are still respected in the scientific and environmental community. They are often considered gold standard or used as calibration references because of their reliability and consistency. So, even in today's world of high-tech tools, gravimetric analysis continues to play a valuable role in environmental monitoring and quality assurance.
I think that's all for our team. Thank you for watching and also listening.